In this case, we can try to run the script and see if we have any errors. There is an error. There is a map function for undefined, which means that somewhere in our code we are performing wrong operation. Obviously, we have a typo. The objects array has been written as the object, and the for loop cannot map to this array. We'll have to fix the same in the last line of the script because we copied and pasted. And at this point, we can evaluate again. And as expected, the rendering reveals the background color where there is no geometry, and the surface color with only the diffuse component of the lighting wherever a ray hits the surface. In order to get the same result as in the viewport, we would have to add a specular component. We'll do this in a later step in the development. In order to get the same view in the viewport, we could disable the specular component in the light and leave only the diffuse. We can also try to increase the multiplier and compare to our rendering. And of course, we can also change the color, for example, to blue, and render again. In the later development steps, we are going to add support for specular highlights, support for ray trace shadows of the lights, support for different material types, bitmap textures, and so on. The alpha channel of the final rendering could be wrong in the case where we are using the GW get viewport device independent bitmap, depending on the type of the view graphics driver. In this case, we are using a software Z buffer during the recording, so the alpha channel is actually non-existent. In order to fix this, we can replace the GW code with a constructor of a new bitmap using the view size, the width and height, and we can also set the color of this bitmap to the background color. If we would evaluate the script at this point, we should get the correct alpha channel, where we get white for object intersections and black 0 for alpha wherever we hit the background. This result could be different if a different viewport driver is being used. Some drivers provide alpha channel, and in that case even the get viewport DIB function would correctly render the alpha channel in the final image. Let's try to visualize how the rays are being generated from the eye position and shot through the bitmap pixels. To do this, we're going to create a tape helper with position equal to the position of the view ray. The view ray starts at the camera, and the target position of the tape is defined by a target object, and this target object will have a position equal to the view ray position plus the view ray direction multiplied by 100. That means we'll place the tape always at the eye point and then place the target at 100 units along the vector defined by the direction of the view ray, starting from that same eye position. In order To calculate